Hi everyone, my name's Aiden, or Ouckah. This is the first episode to a series that I'm starting. I'm calling it My Guide to LeetCode. And pretty much in this series, I'm going to be going over a bunch of LeetCode problems that I believe to be the core LeetCode problems that will help you learn the most common patterns that I see within LeetCode problems. I'm recording this intro post-editing, by the way, so if you see a change of clothes and stuff, it's because this is before I started editing. So anyways, I'm going to hand it back to my past self, and I hope you guys enjoyed the video.
So yeah, let's get started. Since this is the first episode, I am going to be doing the first problem on LeetCode, which is called 2sum. So we're going to be going over two different solutions to 2sum. First one's going to be a brute force approach, pretty much hammering at this array and comparing every single value to each other. And we're also going to be doing the elegant, fancy, never seen before solution to 2sum, where we're going to be using something called a Hashmap, and I'll explain what that is in a second. So yeah, let's go over this brute force approach first. We have our LeetCode problem up. LeetCode always has these two different sections: the name of the problem and the description for it, and the coding part. I'm only going to show the coding part. If you're going to look at the description while we do this, you could pull up a tab of LeetCode. So let's get started. So pretty much the problem, let's read the problem first. The problem says, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So we're going to want some element that we're going to be comparing to. So we're going to loop through every element and have this element I be an element, or the index of an element, that we're going to be comparing to, for I in range of the length of our nums. So let's see what this line of code is doing. So we have some index I, which is going to represent the index of the element that we want to compare to. Let's say we have an array 2, 7, 11, and 15. This for loop is pretty much going to have this I index. It's going to start at 0, so I is going to represent this 2 number. And then as we go through this loop, this I is going to be representing each number in our array. So first it's going to represent 2, then 7, then 11, and then 15 for every iteration of this loop. And we need something to compare to our comparison value, right? So with the brute force approach, we're going to be comparing every single number to another number in the array. So we're going to say for j in range of the same length, let's put in our I pointer and our j pointer. So we have I and j initially at 0. And then in our for loop for I, so while I is equal to 0, we're going to loop j through every element in our list. When we enter this for loop, we get into this for loop, and this for loop is going to be iterating j and comparing it to I and doing whatever we want to do with I and j. So we'll compare 2 and 7, compare 11 and 2, compare 15 and 2. And once j reaches the end, we exit this for loop for j, and we're going to iterate our I variable. So then I is going to push up to 7, and then j is going to be reset back to 0. And then it's going to iterate through the elements again. So it's going to be, we're going to compare 2 to 7, 7 to 7, 11 to 7, and then 15 to 7. And it's going to do that, which is why this is called the brute force approach, because we are quite literally getting every combination of numbers that we could get from this array. Now you know how this nested for loop works. We're going to do the comparing part. So how are we going to compare these two numbers? So first we need to get our two numbers. So let's get our one number, or our num1 is going to be equal to nums I, and then our num2 is going to be equal to nums j. Now we have our two numbers, and let's go look back at our description. So we can see here that it says well, let's see what we want to find first. We want to find two numbers that add up to target. So nums1 and nums2 are going to we have to check if they add up to our target number, right? But there's also another case that we need to take into account. We may not use the same element twice, which means pretty much our I and j elements cannot be the same. So let's do a check for that. So we're going to be check if we are checking the same element. So if I is equal to j, then we just want to continue in our for loop. And this continue just means we're going to break out this iteration of the loop and move on to the next, pretty much like incrementing our j, because we cannot compare two numbers that are the same index in the array. So cool, we have that case. And now if this is not true, as in the two elements are different, then we can check if they're equal to our target. Now we want to check if num1 plus num2 is equal to our target. Then we want to return an array of I and j. So we want to return an array of the 2 indexes that are equal to our target. And as you can see, it accepts our test cases. And when we submit it, it should be all that we need for this question. So it took a while because this is the brute force approach and it only beats 5%. This is why it is called the brute force approach, because it is checking every single combination, which isn't optimal. It definitely solves the problem, but it is not an optimal solution to our problem. So I'm going to show you how we can optimize it with this data structure that we call a hash map. What a hash map is it's like an array where when we want to index an array, or let's say we have an array of 3 numbers, 1, 2, 3. If we want to index from our numbers array, we're going to say numbers, and then in brackets, we're going to give our index, where we index starting from 0. So you get the first number, we'd get number 0, right? And that would give us the 1 or whatever first element in our numbers array that we're looking for. So with a hash map, instead of using indexes, we're using keys. And a key, instead of being a number, it could be anything that you want. It can be a number, so we could have a hash map that represents a array, but there's really no use to that. When people are using hash maps, we usually want these keys to be whatever that we want. So in this case, if we wanted 54 to be our key in our hash map, so if we have a hash map defined and we want to set some sort of key, let's say 54 equal to 1, then we could do that. The key could be a string. We could literally have a string called key be a key and set it equal to 12. And to index that value, we're going to say a hash map key. And then this is going to return the 12 that we set to be in our dictionary or our hash map. To create this hash map, we're going to use something called a dictionary, which is the same thing. It has keys. It's Python's way of doing a hash map. Hash map is equal to these 2 brackets, and these 2 brackets represent the initialization of a dictionary. So we have our hash map now, and we have to think about how we're going to use this, right? I'm not just going to tell you guys how we do it. If you want to skip ahead, I will tell you how we do it, but if you want to hear me explain it, then I'll explain it for you guys. Before we get into this, we have to think about what was the issue with the brute force approach. And the issue with it was when we iterated through the numbers, we didn't save anywhere what those numbers were and what those indexes of those numbers were. It's important that we have some sort of link to the index and the numbers in our array of numbers, so that we can look back at it when we're iterating through the numbers array. Let's take a look back at our brute force approach. We had our 2 pointers, or 2 indexes, I and j, and they would just go through the array and not save any information. We were just looking for a certain combination without taking a look back at stuff that we've already seen before. In our hash map, we see that a number plus the number that we're pointing to right now is in our hash map. Then we can take that from our hash map along with the number that we're currently pointing to and return that as our answer, since they both add up to target. A basic implementation of this, we're going to say for I in range length of our nums. So we're going to loop through all of our numbers again, but this time we're not going to have a j pointer that we're going to be using to compare. Instead, we're going to be saving our data in our hash map as we loop through the numbers. We're going to say our number, or our num, is going to be equal to nums I. We're going to say hash map num is going to be equal to true. So for now, we're pretty much going to say if we've seen this number or not. If this number, it has their value set to true, that means we've seen that number. And then at the end, we're going to print our hash map and see what it is saying. So as you can see in our hash map in our std out here, because I printed out our hash map, we could see that it lists out the number that we've seen in our nums array. So we've seen the number 2, we saw the number 7, we saw the number 11, and we saw the number 15. So now that we know that after we check a number, it'll be stored in our hash map, how do we know if there's a number in our hash map that adds up to num to equal our targets? How do we know that there's some number plus num is equal to target? And how we could do that is some simple algebra. We have to isolate this number, right? So we're going to say minus num, and then minus num from here. So that means this mystery value is going to be equal to target minus num. So if there's a value, target minus num, in our hash map, that means there are 2 numbers that add up to target. So now target minus num is in our hash map. Then we're going to return true. We actually can't return true because it won't let us do that. So we're going to return an array with 1 in it. As you can see, for all of these, it returns 1 because if you remember in our description, all the numbers are guaranteed to have some sort of matching numbers or two numbers that add up to target, right? So it's always going to be 1. Now it's cool to see that we have some sort of indicator that shows that there are two numbers that add up to our target. And to make this even cooler, we could see what those two numbers are because we have all the information here. So we have our num, so we're going to put our num here, and we're going to put our target minus num. And when we run it, we're going to see in our console that it prints out the two numbers that are in our array that add up to, you can see with this case 2, it gives us 2 3s, and you're probably saying, oh, why is it not putting the 2 and 4? Well, this next step is going to show us why it's doing that and how we can solve that issue. And the issue is with indexes. If you remember with our last solution, we had two indexes I and j, and we could check those two if they were the same, and if they were the same, we wouldn't want to do that check, so we would continue in our for loop. In this case, we have no information on what the indexes are, therefore we can't use the indexes in this case. We just have information on whether we've seen that number and whether two numbers that add up together exist in the array. So how we can solve this issue is, instead of saying we've seen it, we're gonna put the index of the number as the value in our hash map. So how our hash map is going to look is we're gonna have a number as the key, and we're going to have the index of that value to be the value. So now we have all the information that we need for this problem. We have all the numbers, we have all their indexes, we have a statement to check if they are equal to, if they add up to target. And all we need to do is do the same checks that we did before. Get the index of this number that we're trying to find by indexing our hash map by this number, and we're going to set our index to be equal to that. So we have all 4 pieces of information now that we need. We have the number, we have the number's index, which is I. We have a checker to see if a number that adds to the number that we're checking currently is in our hash map. We have a way to get the index of the number that adds up to our currently checked num that adds up to target. And now all we have to do is return the 2 indexes. So we're going to be returning I and the index of the number that adds up to target. We need to do an if statement here. So if index is equal to I, then we want to continue. Or we want to add our number to our hash map after doing this check, because if there's 2 numbers that are the same, this is going to override the assignment of the previous number. So we have to make sure that we do this check first to check if the target minus num is in our hash map, and then if not, we want to override the previous index. And that's how you do the hash map solution to twosome, and the basics of Hashmap pretty much, on how to use a Hashmap. I hope you guys enjoyed this video. Be sure to subscribe if you guys haven't yet. I also have a TikTok, which I post a lot of content on, and inspired me to make this content. I do a lot of LeetCode problems during my TikTok live, so if you want to learn more about LeetCode and different skills that you need to have to solve LeetCode problems, I do a bunch on there, so be sure to follow me. And yeah, thank you guys for watching. I appreciate it. And let me know if you guys like this series.